So in the previous class, we have discussed about the terms related to simple pendulum. So let's draw a pendulum first. This is the rigid support to which pendulum is supported. And suppose this is the string of the pendulum, and this is a heavy bob, heavy mass known as bob. This is length of the pendulum. And this is the mean position. When we displace the pendulum from its mean position, we call it extreme position. The maximum height to which the pendulum is displaced from the mean position is known as extreme position. So there are two extreme positions. First, this is extreme position 1. So this is extreme position 1, and this is mean position. Mean position, or we can also call it rest position. When pendulum is left there and it is not displaced, it is not moving, the position in which it rests, it does not move, is known as mean position or rest position of the pendulum. Clear? Similarly, the other extreme position. So on both the ends, it will go up to the same height. See, one complete rotation, one complete to and fro motion. From here, from mean position, it was displaced till here. So what happened is we stored some potential energy in it. We did some work which stored potential energy in it. When we release it, the height of it has stored the potential energy. When we release it, this potential energy is converted into kinetic energy. With increased speed, it reaches position B, and here its position is maximum. So potential energy is getting converted into kinetic energy here, and then from this position to the next extreme position, it will use its kinetic energy to reach the same height, because the potential energy that has been stored in it has fully transformed into kinetic energy. Then this kinetic energy will again be transformed back into potential energy. It means it will reach up to the same height. Then from here, it will go back to the mean position. Now it has completed one complete to and fro motion. It has completed one to and fro motion, which means it has done one oscillation. So what is one oscillation? One oscillation is one complete to and fro motion. Clear? इसके बाद we will move on to the next topic. Next topic we did was Time period of oscillation. Time period. It is denoted by capital T. So time period is the time taken by pendulum to complete one oscillation. Fifth, similarly, third definition we have done is of frequency. Frequency is denoted by small f. It is the number of oscillations done by the pendulum in 1 second, or also known as reciprocal of time period. Here, this is frequency of oscillation. So here we can write the formula as 1 upon f is equal to 1 upon t. Now let's move on to the fourth definition, which is amplitude. See, amplitude is the maximum displacement. Amplitude is the maximum displacement done by the bob of the pendulum. Here, so it is denoted by small a usually. Here, and its unit is in meters. Unit of frequency is hertz or etc. or second inverse. Here, similarly, it is in meters because it's a displacement. So unit is meter as a unit. So if we have to understand what is displacement here, so there could be two ways to measure the displacement. First is along the horizontal direction, horizontal displacement and vertical displacement. Two types of displacements this bob is making. So I'm going to draw a blue line which shows the level of pendulum. Clear? Suppose this is the level of pendulum, and this is the level of its displacement. See, it has been displaced by this length. So this difference is vertical displacement. Clear? This difference is vertical displacement. Vertical displacement. And this difference from here till here. this displacement is horizontal displacement. But what we have to consider is this displacement horizontal. Clear? So it must be equal on both the sides. Amplitude the maximum displacement. If the pendulum was, suppose pendulum were here, so this would have been the displacement. Clear? But the maximum displacement, this is the maximum displacement from mean position to extreme position. The maximum displacement is amplitude. So maximum horizontal displacement is equal to amplitude. Okay. From here, we will move on to the next topic. Effective length of the pendulum. This topic is effective length of the pendulum. So what does it mean? It is denoted by a symbol small l. From center of mass of the bob to the rigid support. This is known as length of pendulum. I'm going to mark it with suppose orange color. So from the center of the mass of the bob to the rigid support. This is known as length of the pendulum. Clear? This is length of the pendulum. Here also I have written length of the pendulum, which is same. Clear? So if we have to measure the time period of a simple pendulum, it is very simple. See, motion of the pendulum is quite fast. If I have to measure one oscillation, time period of one oscillation, it would be very difficult to measure the time period of one oscillation only. If we make one oscillation, it will be very fast. It could be in milliseconds if we take very short length of the pendulum. So we cannot, you see, measure it. So what we do is we do measure a large number of oscillations. Suppose 20, 30 oscillations, 10, minimum 10 oscillations we do. Okay. So when we do these 10 oscillations, so we will always be able to measure the time period of oscillation. Suppose this oscillation, this pendulum is doing oscillations. So it will be very quick process. We will not be able to, you know, notice how much time has lapsed in one oscillation of this pendulum. So what we do, we start the stopwatch and release the pendulum from here. So it will start doing oscillations, and we will keep a count of oscillations it has done. One complete two information. Suppose this has done 15 and 16, 17, 18, 19, 20. We will stop the stopwatch from here. So now we will divide the total time of 20 oscillations by 20. Then we will get the value of each oscillation. Then we will repeat this experiment different time. So if there is any error, it will be removed. Suppose we have taken 10 readings of 20 oscillations. So we will divide the total time period by 20 each time, and the table and see. So far we have understood that the length of the pendulum is directly proportional to the time period. So inverse of the t square means length of the pendulum divided by the square of the time period. There is this ratio they are calculating. It is 25, 25, 25. This is constant for all the different lengths. Again, I am going to explain the readings which are given here. First reading of the pendulum was taken with effective length of 25 centimeters. And it takes 20 seconds. See, 20 oscillations to complete. See, 20 oscillations were completed in 20 seconds. If we have taken the effective length of the pendulum as 25 centimeters. So it means the time period of each oscillation is 1 second. And if we square the time period and divided by the length of the pendulum, it is 25 centimeter per second square. Clear? Similarly, if you have increased the length up to 36 centimeter, the time period for 20 oscillations for this length was 24 seconds. Each oscillation was done in 1.2 seconds. And if we divide the length of the pendulum with the square of the time period, we again get 25. So again, similarly for different lengths, the division of it with the square of its time period is constant throughout this readings. You can observe this. It's very clear. For 100 centimeter length, 2 seconds was the time period, and we divided 100 by 2 square, we got 25 again. So in this way, we can establish this, that for any pendulum, the ratio of its length and the square of its time period is constant for a given period of time or given length of pendulum. We can always, in any pendulum, we can observe this. Clear? So directly proportional graph is very easy to make. We just have to draw an inclined straight line. That's it, which represents that the quantity at x-axis is directly proportional to the quantity at y-axis, or vice versa. Suppose this is t square and this is length. So we can easily observe that it is constant. So time time square versus length graph will be a straight inclined line. Clear? Suppose these are any two positions P and Q. The time, suppose for this length L1, suppose this is the length L1, the square of the time period is T1 square. Here it is T1 square. And at this position, L2 length, square of the time is T2 square. In that case, if we find the slope of this line, what is slope? Change in y-axis upon change in x-axis. Clear? So next part is slope of the straight line. Slope of p raised to power 2 versus length graph. So what does it mean? I'm going to let you know. See, any slope graph of any slope of any graph. Suppose this is any graph and this is a line. So there is some change in y-axis and with respect to change in x-axis. So this is suppose this is change in x-axis and corresponding to which this is the change in y-axis. Slope means change in y-axis upon change in x-axis. This is the universal formula for slope of any graph. Clear? Change in y-axis upon change in x-axis. Similarly, for slope of t square versus length graph, it will be what? Change in y-axis upon change in x-axis. So slope will be equal to t1 square minus t2 square divided by L1 minus L2. Clear? So by observation, and this is constant. We have by observation we know. See, by observations we know that this part is constant for a place. For a place means when value of g is not disturbed, the acceleration due to gravity is not disturbed. L upon t square is constant. Similarly, t square upon L is also constant, which means clear. So this slope is constant for a place. Constant for a place. Clear? Means if acceleration g is constant. Clear? So what is the constant value then? So by observations we have find that by observations was found that slope is equal to t1 square upon minus t2 square upon L1 minus L2, and which is equal to 4 pi square upon g. Clear? So 4 is a number, pi has a certain value, which is also considered to be constant, which does not change from place to place. And if g remains constant, then this whole slope remains constant. Clear? You have to learn this formula. Clear? So if you have to calculate the value of g, what we'll do is the new value of g will be equal to 4 pi square divided by slope of t square versus L graph. Simple. This is the new definition of acceleration due to gravity for you. Remember this. Clear? Now, we will discuss about the factors affecting the time period of simple pendulum. Next topic is factors affecting time period of simple pendulum. Hmm. So first part is first factor. We have already discussed about it. The time period of oscillation is directly proportional to the effect to the square root of its effective length. Simple. It means the observation we have found that time period of simple pendulum is directly proportional to the square root of the effective length of the pendulum. Simple. It means if we increase the length of pendulum, time period will also increase. If we decrease the length of pendulum, the time period of pendulum will also decrease. Clear? Which proposes that frequency of the pendulum will follow inversely with the length of the pendulum. Simple. Now let's move on to the second part. The time period of oscillation is inversely proportional to the square root of the acceleration due to gravity. Clear? This is the second part. Again, by observations, we have found that E is inversely proportional to time period of the pendulum is inversely proportional to the square root of acceleration due to gravity at that place. Clear? It changes from place to place. You must know this. Acceleration due to gravity. So at poles, G is greater. So G अगर poles के हम ले लें at poles, it means the time period will be more or less. Any idea? See, this is at equator. Suppose the time period is T1 and here it is T2. So definitely it is inversely proportional. Value of G at poles is greatest. So it means T1 will be lesser than T2. Acceleration due to gravity will increase the frequency of the pendulum. It means time period will decrease. Clear? Simple. Now let's discuss the factors upon which it does not depend. It does not depend upon the mass or amplitude. Clear? So it does not depend upon this. Let's also mention this. It even if we see tie up a whole mountain with a pendulum or 1 kg mass as bob in the pendulum, if the effective length of both the pendulums is same, then their time period will be same. If they are being measured at the same place, means the value of g is same, there will be no change in its time period. So this is very popular question with teachers to ask. If what if we increase the mass, if we double the mass of the bob, what will be the change in its time period? There will be no change in time period. Remember this. The time period of oscillation does not depend upon the mass or material of the body. Remember this point, very important. Clear? Suspended, or which also known as bob. So this point is very important. I am going to mark a star over it. Otherwise, first 2 points are also important, but you must always know better where it does not variates, what factor does not variates it. So another was the time period I have already discussed in the previous class. Time period of oscillation does not depend upon the amplitude of the pendulum. Clear? Simple. So these two factors are representing or telling us about on what factors the time period does not depend. It's also very important. Simply the final expression for time period will be what? Final expression for time period. Final expression for the time period. It means the final formula. So it will be time period is directly proportional to the square root of the length and inversely proportional to the acceleration due to gravity, square root of the acceleration due to gravity. And 2 pi is the proportionality constant. By experimentation, we have calculated this value 2 pi. Okay. All these are observed values. So this is the formula you have to learn. I'm going to make it important by enclosing it in 2 boxes. Shows it is very important. You have to learn it. Clear? So what are the variables? What are the meanings associated with the variables in this equation? T is the time period, L is the effective length, G is the acceleration due to gravity. And for seconds pendulum, see, seconds pendulum, nothing special is there. What is second pendulum? This question is also asked many times. Seconds pendulum, it's nothing special. Just a pendulum with the time period 2 seconds. Second pendulum It is the pendulum with time period equal to 2 seconds. Clear? So my question is, what must be the effective length of a second's pendulum if acceleration due to gravity is 9.8 meter per second square at equator? What must be the effective length of the second's pendulum? This is the homework you have to do. Okay. So that is for all today. So have a nice day.